Yeah, so let's just first start with why do we want a hardware descriptive language? One second, just give me a moment. So there's a first start with why do we want this language? We cannot design hundreds of gates at one simulation for a particular design. If you like it, if you imagine a particular design, it will require hundreds and hundreds of transistors. So that's why we cannot design schematic entry for large designs. And those complicated designs can be very easily done by these hardware descriptive languages. For example, we started with VHDL and then we have started using Verilog now. Many people now use system Verilog as well for some design language, for some designing blocks as well. And here, it can support behavioral and structural description. So behavioral is something like there are different types of modelings in Verilog. So behavioral is something like, the designer doesn't have to know about the intricate details of the design, like what gate is lying at what level of the design. He just needs to know that what upper level logic he has to implement, then he will be able to implement the logic. And gate level logic goes down to this level, as you can see. This is what we call the behavioral level logic. And yeah, so there are different modeling styles in Verilog, as I have told you. First is the behavioral modeling. Modeling can be implemented in terms of designed algo without concern for the hardware details. For example, if you see this design, this is the behavioral logic. The person doesn't have to know what is the gates we are using. Like he cannot be aware of this fact that as well, that we are using AND gate and OR gates over here, but still he can write this logic over here, because when S is equals to 0, then only you assign the value of A to F. Otherwise, you assign the value of B to F. Just that's it. It's like, no, that's what normal C people can also do. Like normal software people can also do. Sorry. And here, this is the one RTL data flow modeling. Here, designer is a little bit aware of the hardware, what is going on inside the logic, and like how he should design his thing. Now this is the gate level modeling. Gate level modeling, then in this one, we write the codes in terms of our gates, like whatever gates we are using, AND gate, OR gate, and XOR gate. So if you'll see the gate level modeling, they're like, they particularly use XOR instances and OR instances over there. And this is transistor level modeling. It is implemented in terms of the transistor. This is also called the switch level modeling, which is very less used. And in this, if you see this is behavioral level modeling. The code it is just dependent on the logic. It doesn't go to the level of the gates. So the code is also very less in the upper. So as we go down, the time also increases, like the time of the, because since we have more lines of codes inside, therefore the time of the execution also increases as well as our code increases, because we have more gates and we have to implement those complicated logic. Yeah, so now what is the differences between this high level language and the hardware descriptive language that we use? So here, hardware descriptive language, as in like the Verilog and what normal software engineers do. So here we have instances, there we have functions. So here we have to call functions, and then like for example, in the high level language, they just define functions. They do not have instances to instantiate. Like here, when we'll see one code, then we can see in that case that how we instantiate our instances. So here we have instances. We do not we can have functions inside our modules and everything, but there's a difference between how we instantiate things and how we have a function call. And the things are executed sequentially in the high level language in C. Like the other code comes after only the execution goes to the second line of the code only after we are done with the first line of the code. Here, all of the code goes at one point. There is no like first will finish first, and here a second will finish after. Like there are lots of initial blocks that we use. And here there's one more difference. Like here we use the time, there we have the execution, like the execution time. Here we have the time. Here we are dealing with the real hardware. So that's why we are very fast over in the hardware descriptive language, and there we are a little slow because we have seen, like, for example, if you are using boards, then the output comes very fast. And like, why do we use hardware descriptive language? One more point is like, it is letting us verify something. This Verilog, we can design various blocks just by writing a level of code. And Verilog is also used for verification as well. And there is one more enhanced version, System Verilog. So we are able to verify a piece of code without having any kind of hardware. We do not have to go to the labs and, like, for example, we are verification engineers. We do not have to go to the labs to verify our outputs. We just have to sit over here and write our stimulus and sequences inside our laptop. We do not have to go to the lab. So that's one major advantage which comes with this Verilog language, that we can verify the code just by sitting on our laptops. Like, we do not have to go to labs. Yeah, so here are the test bench components. For example, this hardware descriptive language is very different from the VHDL, Verilog and VHDL. VHDL was kind of difficult to learn. For example, I also do not know how VHDL functions, but Verilog is very similar to what is in C. Like, C is very basic language. So C has lots of other types of storage elements. For example, int unsigned ends, but here we have registers. Like, we have this reg storage element, and then we have wires. These are the other storage elements, and then we have some other system tasks as well. $monitor we use to, like, display things. So you want to say something, Arjun? Okay, initial blocks. So there are different types of blocks that we have here used for initializing values. So there are different types of initial blocks. So the alarm says that it's executed once and only once, and all initial blocks starts executing at time 0, and for multiple statements begin and end here. So we can have multiple initial blocks inside our test bench. All the initial blocks will, like, will go at one single time inside the system. It's not like if you write first initial block at one in the upper part of the code, and you're writing the second initial block after it. It doesn't matter that, the positioning of the initial block doesn't matter. All the initial blocks are executed at one point. So here are the system tasks that I was talking: $monitor, $strobe, and $display. This is for the dumping of the variables that we have: dump file and dump vars. We'll see what is the difference between these things. Okay. So here, this is what a module looks like in a Verilog. So here inside a module, we can have different types of things. Like, we can have parameter declaration, we can have inputs and output declaration, and what is output declaration and out declaration. Net is basically the wire, reg declaration, time declaration, integer declaration, and real declaration, and events. So these are some little complex parts that I'm coming at: event declaration and gate declaration and UDP declaration. So these, I won't be going through those UDP and functions or tasks inside this PPT. And we have continuous assigned statements: specify block, initial statement, always statement, and module instantiation. This is for the instantiation of the design. That's I was talking about, that we can have multiple instantiation of the same module as well, but multiple instantiation of the same design. Like, this is what a test bench looks like. So here, these are the blocking and non-blocking assignments are provided to control the execution order within a always block. So for example, we have a always block, and these are two statements here, and there are two types of assignments: blocking and non-blocking assignments in Verilog. So this one is the blocking assignment. Here, this blocks this execution of the second line of the code until we are done with this one. So here in Verilog, like, we have a lot. For example, if you're writing something in Verilog, then you'll face a lot of timing issues. That, for example, your design is supposed to make a particular signal 1 equals to at a particular time, and your checker is checking at that point. So, but sometimes what happens that the design is also going high at the same point, but still your checker fires because just because there is some timing violation between them. So you know that timing things are very important in our electronics world because of setup and whole time violation. So that's why we have different types of these assignments. So this one, in this case, the value of b is equals to 1, a is equals to 1 after ordered execution. Okay. And this is the non-blocking assignment. In this one, the value of the execution of the second statement is blocked until we are done with the first statement. So here in this case, this is also going at the same point, and this is going also in the system at the same point. So here a, and you have initialized the value of a is equals to b equals to 0. And then okay. Can I take some feedback that if I'm going very fast? One second. Can you guys please write, like if I'm going very fast, I can be very fast sometimes. You guys are able to understand, right?
Yeah.
Yeah. Okay, then please write on the chat box if I'm going very fast. So here in this thing, this is blocked until we are, sorry, no, this is not blocked. Both of them are going at the same point. So a is equals to 1 at the same point and b is equals to 0. Because initially it doesn't wait until this is done. It takes this value, a is equals to 0. Yeah, that's how this is also saying that we have always block s is equals to 4 and a is equals to s. Then in this case, s and a both will be equal. And in this case, s is equals to 4. And then, for example, a is equals to initialized to 2. S is initialized to 2. Then a will take that initial value instead of waiting for this to be evaluated. Okay, so the data types, let's talk more about the data types in Verilog. So the data handle in Verilog fall into two categories. Mostly we use two categories. So we have net data types, the term, wire, and net. Like we have this net data types, the term, however, the terms wire and net are more often used interchangeably. So usually the default value of the net, like wire, is Z, but there is one exception. The strirage is also a net, but it defaults to a value of X instead of C. So this is one exception. So this is one important question for Verilog. And for variable data types for storage, we have registers and we have integer here as well. And for having decimal values, we have real. You can use real or real time for storing the decimal values. Real time. These things have decimal values as well. This can store decimal values. So a net signifies a connection from one circuit to another circuit. For example, this duty to another duty. It's like basically just a wire. It doesn't stores anything. It is just have to save a connection between these two duties. And that's what I was saying. It seems the same thing, that it represents a simple wire connection during an interconnection default Z. It is same as net wire, but it can be driven by more than one signal. Default value is X. So this is the different kind of wire or net we have. So register is basically supposed to store a particular value inside a circuit. These are like normal things that we have. And this one, this is supposed to, and there's difference between registers and wires. These are very important questions. Registers, you can't have procedural continuous assignment for them. You cannot assign something to this registers outside these always block or initial begin blocks. Like if you, for example, write something over here inside reg C is equals to A plus B, it will straight away throw an error. But if you'll write wire C is equals to A plus B, then only it will execute. So that's what another part, difference between registers and wires. But registers are only for the modeling of model. What is the behavior of the circuit? So this one is not a register because it's register C at the rate E and B. You want something like a, you want the circuit to, like, normally we write like this at the passage of clock. You do not want to, like, one of them changes, then you assign something to C. Otherwise, if you want to model a circuit, then like these have to go above this. It doesn't comes inside this. If you want to model a combinational circuit, these have to be inside procedural assignment, not continuous assignment. We'll see what is procedural and continuous assignment. So we can have different strength levels for the wires as well. For example, we have different strength levels. Like we can have supply strong. Like I don't know if these are available in the books or not. These were inside my notes that I had for my engineering times. So okay, yeah. So the net types can have different types of strength levels, and it can be like these strength levels that you see: supply, strong, pull, large, weak, medium, small, and high Z. And these are the driving types. These two are driving. These three are the driving types. This is the storage type. This is driving, and these two are storage, and this is high impedance. And this one is the strongest one, and this one is the weakest one. So what thing comes over here is like, for example, two signals of unequal strength and driving on a wire. The strongest signal only prevails. So, for example, if you have two signals of strength, strong, and weak, the result of the signal will be shown by this strong, not weak. So this one has to, like, wires can have different drivers, two drivers, right? So which one, whatever is the stronger one, that will prevail. So these are the system tasks we have, like okay. If you have some doubts, you can write in the chat box. We'll take it in the end. The system. So one important question that comes for Verilog is like, what is the difference between dollar monitor and the dollar display and dollar strobe? So, and for dollar monitor is used for monitoring a signal. The catch here is like one test bench can only have $1 monitor, one module, because it is involved only once. If a program has two monitors, then the second will be executed. So the first monitor doesn't get executed. You can have multiple display statements, but you cannot have multiple monitors. So even if you have multiple monitors, it will not throw error. Only the second monitor will be printed. So and monitor is something like it will keep displaying, and whenever it sees there is any change in whatever value it is displaying. So you won't be able to debug this very easily. So there's only one monitor. And this dollar stop is used to provide a stop during a simulation, and it puts the simulation in interactive. It is not terminating the simulation. So there is a difference between dollar stop and dollar finish. So it is used whenever the designer wants to suspend the simulation and debug the simulation from interactive mode. So it is used to put the simulation in interactive mode. Dollar finish is used to terminate the simulation. The simulation will just finish, like it's not stopping over there. Dollar strobe is used for printing at the end of the simulation. It is at the end. What are the values at the end? It's not like monitoring every time. Okay, so there are different types of delays we can have. We can have inter-assignment delay, and we can have intra-assignment delays. So this is one important question. Here in this case, we have these values. Assignment happens 15 seconds later. Here, 15 nanoseconds later. For example, if the time scale is 1 ns by 1 ps. So here, there's a difference between these two things. It is not like here the assignment is only happening 15 seconds later. The A will have a value of X until we reach the timestamp of 15 seconds. if you have a dollar display before that, then A will not have a value of that value like of 0. It will still have a value of X. But here in this case, this is an intra assignment delay. So delay evaluation, that the evaluation is happening at the A by B is happening at the 0 time only, but it will be assigned to D after 10 seconds. It doesn't happens like, you know, the assignment and evaluation is happening after 10 seconds. For example, if you have like 10 seconds A at this value, then like assignment will only happen at the after 15 seconds. But this one is assignment is you evaluate the expression, you keep it with yourself, and you assign it only after 10 seconds. So these two are different, like intra and intra assignment delays. So we can have two different types of connections. First one is like ordered list positional association, and second one is a named association. So this one is the module. For example, if you have some, I do not have any logic over here. This is one input A, B, and output C. It's here. What you have to do is like you just instantiate the module like A, B, and C. So it will map like this. For my convenience, I have used the same naming convention for them. You can have C, D, E over here as well. It's just that the first value will map to this A to A. It's not A to, it's like the first will map to this first. Second will map to this second. Third will map to this third. And this is the positional association. So there's a comma missing over here. So not take that. So here it means that the A over here belongs to the A over here. So this one is the value which is here. So A here belongs to A here. B here belongs to B here. So this belongs to this place, like wherever we are instantiated. Like what is inside the bracket belongs to that place wherever we are instantiating. Here C belongs to this place, and this C, I have missed out a C over here, and C belongs to this place. So you can have different conventions as well. Usually people prefer named association because we have, like in our design, we have like 50 signals over here. So it's better, like rather than having a positional association where people have named associations. So there's one more important part, that is equality operators. So this is logical equality, and this is logical inequality, and there is like triple equal to. This is case inequality, and this is case inequality. So there is a difference between these things, like triple equals to and double equal to. So like usually, like when we are doing our projects, we do not give our stimulus as X, but when you start working, then the main issue is like, the main issue comes when some signal is going X or Z. So mostly people use this or this. So what happens here, like if any of the operands, example, let me take a notepad. Let me take a notepad and explain this. Okay. Okay, so this is A. We have 0, 1, 1, X here. We have 0, 1, 1, 0. So if we do A equals to B. So if any of the operand is X or Z, then the result is gonna be X. Here also X. The result is gonna be X. If any of these operands are gonna be X or Z, then the result is gonna be, then this is gonna give me X. And now, for example, if I change to triple equal to. So in this case, what it will see, it will compare 0, 0, it will compare 1, it will compare 1. All of these match, but X is not equals to Z. So it will give me a value of 0. And for example, this value is X. Then this comes up to be 1. So it happens like this, like it considers the X or Z as well. Sorry, this is triple equal to. I haven't given triple equal to. So yeah, this is how this A equals A triple equals to B matters. It takes X or Z inside the equation as well. It compares them. And vice versa, the not equals to app works. So we can have like array types for the vectors as well. Netso registers can have multiple values inside them. For that's why we have the array types. Like they can for saving multiple values inside them. They can be of different width. That's why we have this, like you need different widths, right? Like for example, larger, you cannot work in 1-bit operations. Yeah, so this is the always block. Okay, so this always block works like if there is any change in X or Y, then this always block, like whatever logic is going inside this, that will be invoked, like that will become active. And since we have a begin and end over here, this will have a sequential execution. The C will not be evaluated until this S is evaluated. So this has a sequence over here, but we have one. But wait, for example, if it is not inside our always block or not inside our initial begin block, then the sequential execution doesn't happen. So all the things are happening at the same time. This is getting evaluated at time t0. This is getting evaluated at time t0, and this is getting evaluated at the same time. So, and for example, even if you give there are different timing zones in Verilog and system Verilog. System Verilog has very diverse timing zones for the assertions and all, but even if you give #0 over here, the #0 gets evaluated a little after in the system after the normal statements. So #0 sometimes saves things. And this is we have procedural statements and we have continuous statements. Continuous statement are outside the always block. That is like used to model the behavioral combinational logic. Sorry. So this is evaluated in the order in which they appear in the code, which is sequential. It must be inside an always block always. And the reg should always be inside a procedural assignment. It is not, that's what I have told before as well. I go, sorry. There is some noise coming from someone. Oh, sorry, I just saw the message, which is, so this is one thing, one question that we have, that what is the last assignment which will happen and will happen at what time? Can we unmute everyone now? Hello?
Yes, ma'am.
Can we unmute everyone now?
Yes, ma'am. I made. Yes, ma'am. I have given the access.
Okay, yeah. Thank you. Sure. So I want to ask someone this, that what will be the last statement in this case? As like it will be executed at what point of the simulation then?
60 nanoseconds, ma'am.
16.
Which one? Like for A or B? You're saying
30 nanoseconds total time.
Give the answer like this for A and for B. Are you guys answering for A first? So let's take A first.
Yes,
A for
16
0
0 at
nanoseconds.
0 nanoseconds. 16 nanoseconds D last statement.
Yeah, it will be 60 nanoseconds because since we have a begin and end over here, this will happen at 0 time. This will happen at 10. This is like getting incremented, and then 40 and then 60. And what will happen in this case? We do not have a begin and end over here.
So this is 30. 30 nanoseconds total time.
Yeah,
30
yeah,
for
this is going to be 30 nanoseconds because we do not have a begin and end. All the things are going at the same point. And this question, example, if selection is X, then what will be these values? And then what will be the value of out if this is X?
0.
0.
Why do you say it is 0? Can you explain? Hello?
1 it would be.
No, why do you say it is 1? Like I want the answers with the reason as well.
Any non-zero bit is considered as a 1.
No.
I think it will be
It will be?
high impedance state inside. High impedance state.
Yeah, it won't be driven, right? If the things are going X, and like I will not say high impedance state. If this is getting evaluated over here, you know, this is setting over here, then it's just everything is going inside. Whatever is going inside that, no, that will go X. That's what happens. If this is X, then your out is gonna be X. Okay, then Jill, let's leave it. Let's take questions.
Ma'am,
Is there? Yep.
ma'am, while we write a Verilog code in Vivado or something, so if we don't give any input, the outputs are at high impedance state. No?
If you
Yeah,
do
if we
not give
don't
any,
give any input, so input are like X. Oh, is it? I think it's
no,
the
it
reverse.
depends.
I think input,
No, it depends on what is your output. For
Mhm.
example, usually we declare the output as wire if you're doing the continuous assignment, right? If you're doing a modeling a combinational logic. Now, if you have is at register, if you have that output variable declared as register, then if you're not driving anything, that is the default value is going to be X only. That's what you're asking.
X only. Okay.
Yeah. But it
Yes,
depends.
yes.
But it
Okay.
depends. Like, what is your so what is the type of the output that you're connecting to? Usually the output is connected to wire only, so that is gonna be Z. Any further questions that you guys have from like the important things are from Verilog that I can say that
Excuse me, ma'am.
you got A and B. I have A and B here. I have S here. I'm taking the carry from here. So here in the first instantiation, this is what I'm doing. I'm taking the XOR of A and B. So this employs XOR. This is bitwise operation. So it will happen on each and every bit of A. For example, for now I have A as only 1 bit. You can have it as 4 bits as well. And this one is an AND, like, to be basic. So here, whatever I have, I'm getting from the S. Like S is going as input over here. C is the another input which I'm feeding into this module. And then I'm calculating the sum underscore final over here. And this is carry underscore F from the circuit. Finally, for the final carry, you have to take the OR between this and this. That's how it goes, right? And I'm giving, this is an initial begin block. We can have multiple initial and begin blocks as well. But for both of these initial begin blocks will go into the simulator at one same point. And this is the monitor, and monitor is like, if you see, where is the, yeah, I have just one monitor, and monitor is like kind of displaying the values whenever there is a change in this parameter. So I have like 0 time instance and this 10 nanosecond times stamp. But if I'm feeding one, A is equals to 1, B is equals to 1, C equals to 1, then I have these values. S, this is my S. S is equals to the sum. This is the final carry. And if I'm feeding these values, then I have this. So coming back, he forgot to start recording. second. Let me go to above. What if I always see, what does that module always at the rate star means? These means like always at the rate star means, like for example, if there is a change in, if I write an always block over here and always at the rate star, just like this. Then it will just see all of the parameters, all of these values inputs I have. If anything will change, it will take any of these signals change, then no, then and in that case this always block will be invoked. And this begin and end, we write it like this inside this. For example, this is an initial begin block. You can write it like this. And inside here also you can write in the similar way. Always block we're writing in the module, like how if this signal goes high and that like that. And you were asking about the hash delay, we just write it like this, and it goes in the nanoseconds if you're not specifying any time scales. Otherwise, you can specify a time scale. Usually the time scale falls in 1 nanosecond by 1 ps. Okay, where is this? You refer a VLSI Verilog learning basic or it. So is this Madhav, is this part clear for you now? Like how did you understood, like how do we write always blocks and how do we write, how to write it? You can reply on the chat box. Okay, then let me go back to the another question. Yeah, thank you for your reply. So you will refer I usually refer the most basic book is the Samir Palnetkar that I refer, and usually you can, for internet you can just go to Chip Verify, and Stack Overflow always works. If like after you have, but for learnings you have to read Samir Palnetkar and practice over here for starters. System Verilog also works in Leopold Playground. And otherwise you can download the crack version of Mendelsim. Yeah, this one. Ma'am, it is possible to assign. Okay, how it is possible to assign? Like I would like to know, because for me it always gives errors. Someone just Karthi told me how it is possible to assign. I didn't understand this question. That's I'm asking to Karthi. Okay, then let it go that question. Anyone else has any doubts? I do not see I do not see any other questions over here. Like any other doubts from this PPT actually. Everyone understood the difference between dollar monitor, dollar strobe and dollar display? Everyone knows this difference? This is very important question. Okay. Let me go through my slides again. Okay. This is so annoying. How does this go? One second. Oof.
Excuse me, ma'am. You are muted, ma'am. Yeah, yes, ma'am.
Yeah, I was put on mute actually. So let me I'll explain the non-blocking statements from the beginning. This is the module. So what I'm saying is like this statement at the 6 is not waiting for the statement at 5 to finish. So that's why you see this A is equals to 1 and B equals to 0. It is not taking a value of 1. Otherwise, if it would have waited, then it would have assigned the value of 1 instead of 0. It's just taking this initial value. And if we write it as 1, and these, see, this is the difference between the blocking and the non-blocking assignment. This is waiting for the first to finish. And we are inside an initial begin block. These will be executed sequentially only. Let's take things. Don't tell any specified block. Okay. If there's two, how much enough for verification? Let's see. Dollar strobe is like just dollar strobe is the format is just like dollar monitor only. You just have to do the same thing. It is just that it will be displayed at the end. Let's do dollar strobe. Not here. Here we'll do a dollar strobe because I do not have any time stamp over there. Dollar strobe is this. Second. I'm skipping something over here actually, maybe, but dollars. I think I'll have to look at this part again. The dollar strobe works just like the dollar monitor. The formatting and all is exactly the same, just how we use printf and scanf and C. But it's just that the dollar strobe is displayed at the end of the simulation. I think I'll have to get back at like what is the issue over here. Maybe it's having some issues in the code. I'll have to debug. This will take, I don't know. I don't want to kill time on this. There are two initial begin blocks which doesn't include monitor. Does the monitor will display? It will take the second one. It's like this one, this question. The answer to this question, it will take the second one, like the how is it's taking the on the sequence of the code, not like no, not on the sequence of the time. It is not taking the time. Like whatever is the second monitor, it will take that. Because anyways, it's not the monitor is not dependent on the timestamp. It's like whatever value is changed will change over here, then it will change according to that. How much enough for verification engineer interview? So this is verification engineer interview. This is not you'll have to, there are many other things as well. We'll have to know that this one's difference between monitor and dollar displays. You can have multiple dollar displays inside a module, but you cannot have multiple dollar monitors. As I said, only one monitor will be displayed. Yeah. You can have like at dollar display is like, you know, we can, it is used to debug something like at what instance, what value we have in that particular signal. So it's more of like a debug thing. Dollar monitor is like how many times you have, you'll have that dollar display for that time only. For example, here, the comment of this code was working, right? Something has happened. Okay. This should work now. Yeah, for example, here, if you see, right, I do not have multiple dollar monitors over here. I just have one monitor, but still it is displaying many times. It's displaying 2 times because my time variable is changing. So And if you'll have this as $display, then it will just display once. It will not display twice. Now, I think this $strobe should also work. Yeah, this usually the strobe is 1 and this is the other one. Okay. Ma'am, what is yeah, I have covered the difference between monitor and display. You can have different displays, lots of displays, but one monitor. What is design and test bench in that window? This is design. This is the design. I'm just the designer sitting over here. Testment is basically just giving the stimulus, and I just randomize the stimulus and I'm just printing it over here. Design is sitting over. I have just written it in a different place. That testbench.sv design is here. I'm sorry for that confusion. Why did I write like this? But it can be at any place. Anyways, it's just like, like just for the compilation part. You can write it here, you can write it there. There is no hard and fast rule that EDA Playground has. Yep. Go back. System tasks. Someone told me in the beginning only to show all my slides. Let me go through my slides again. So why do we have a hardware descriptive language? If anyone has a doubt, then you can post a question over there. And then we have different modeling styles in Verilog. Like in the same code only, we can have different, like you can just put in behavioral modeling or RTL modeling. Usually this, just give me a moment, 1 second. Yeah, but usually nobody writes till the gate level modeling and nobody writes till the switch level modeling. People usually stick to this RTL rather than having behavioral modeling. Many people write that as well, but like the verification, like all the design of a chip functions like this only. First is like you have the designers design their things. We have the digital design team, and then like the verification team is also working at the same time, and then the design goes to they have to do the gate level simulations, then it goes to the physical design engineers. So at that time these people, they go to the gate level modeling and they have to connect everything if something is not connected. And what is the differences between HDL and HL? These are the differences. What do we have as the test bench components? These are the test bench components. And what we can declare inside a module, these are that things. And blocking and non-blocking assignment, I have already explained twice. Data types in Verilog, we have whatever reg, and these are basically reg and wires. Registers, and we can have different strength levels as well. The system tasks, someone was asking the strobe, this just prints at the end of the simulation to provide us, and these are like whatever system tasks we have. And types of delay, this is very important concept. Like if anyone has a doubt, then you can ask what is intra-assignment delay. This is different than this. How these things are evaluated, people are asked this. And the different type of connections we do. Make sure you do just one type of connection at one time. Like one is combining ordered list or named association. People stick to this named association. You can have different names as well over here. This is also a very important thing. If anyone has a doubt, you can ask me. What is the difference between case equality and logical equality? Because these two things are different things. I explained this on a notepad. These are simple vectors. Always block procedural statements. And this was a simple question. These two questions that has been already done. Let's see the questions. Register transfer logic is like just the RTL coding that we do. It's like the RTL level modeling. it's just the logic that is sitting over there. It's nothing like it's just in terms of the registers. If we miss any parameter in sensitivity list, I didn't ask this question like what if we miss any parameter in the sensitivity list, then your always block won't be activated. Name blocking side. Okay, so 1 second, let me if you're like if you miss any parameter in the sensitivity list, this will be something like it's just that you want your always block to be triggered. If that signal is gonna be gonna change, then your always block won't be triggered. That will be the complications of it. Okay, please show blocking slide. The blocking slide. Yeah, this is the blocking slide. What will be the difference in output if we use intra and enter delay? So there won't be any difference in the output as such. We'll still have it's just that the internal mechanism, how it is happening. So if you have the intra delay, then it's just that the evaluation of A by B will happen at the time T0 only. It's just that the assignment today won't happen at that point. Yeah, take this. There won't be any difference in the output because we are doing that for the value of D. I'm just trying to explain the mechanism of it. Is that clear, Ashwani? Any further questions? Any further questions with the logical equality and the case equality? So Sagar, are you done with this slide? Anyone has any other questions? Okay, you people understand this, right? This is important. This is Verilog interview question as well. What is the difference between this and logical equality and case equality? Okay. So nobody has any questions. You people understand everything, right? Anyone going to are you people going to respond something? For example, am I on mute? Explain present slide.
Yes, ma'am.
Which slide you were talking, Teja? Which slide exactly? This equality operators.
Yeah.
Oh, this. Yeah, let's see this then. Example, you have this, you have this, and you are doing A equals to B. Okay. And then if and you have some things over here. You know, this X is equals to A plus B or something. This statement you have. And your A is this. Let's take this down. Okay. So your A is this and B is this. It will see, it is doing a bitwise operation. 0, 0, it will compare, 1, 1, it will compare, 1, 1, again it will compare, 1, 1. And as soon as it will encounter a X, this expression is going to be X. And that is unknown. You will have an X and this X will be also unknown now, like whatever is lying inside this. So it happens like this. And as soon as you're doing A equals to B, that is triple equals to's. Then here in this case, what happens? I will see that these three things are same. Like all the first 4 bits are going to be same. Then it will see X is not equals to Z, then it will not go inside whatever is here. Like some logic is here, okay. And we have this else part. It'll go inside this logic one. It will go and execute this because this value is going to give me 0. Here, this is the result, and this value is going to give me X. And now, for example, let's take another scenario where we have this as ZX. You got it? Okay, cool. In this case, the result will be 1 because it's going and comparing everything. It's a cool thing. It's a cool feature that Verilog has. Anyone has any other questions? These are my slides. If you want to see them, then I'll just go through them again. Modeling styles in Verilog, HTL versus HL, test components. Some of these things you might not be understanding in this because they cannot cover them in one class. Blocking and non-blocking assignments, data types in Verilog. I'll just go through them again. Anyone has any further questions? I'm asking again, otherwise. Sorry. Can we end this then? Rajat?
Yeah.
Okay, so
Like, anyone have any doubt?
Abhishek has
So-
asked one question. Can you please repeat intra and enter delay? Let's go there. Just one question. Lost this. Yeah, so what I'm trying to see over here, A is equals to 0, hash 15A is equals to 0. So this is a normal inter-assignment delay. Assignment happens 15 nanosecond later. So at the timestamp till 14.99 nanoseconds, your A is equals to 0. That is not going to change. So assignment is happening at that point only. So here in this case, this is called an intra-assignment delay. The delay evaluation happens at this timestamp of 0 only. But here the value gets assigned to D at after 10 nanoseconds. So you have the A by B with you, but you do not assign it to D. And for example, 1 second. 1 second. Yep. Let me write over here. Is equals to so here in this case, this whole statement is executed after 10 seconds, 10 nanoseconds. It's not like the C by D, you will have the C by D with you at the 0 time, and it will be evaluated, it will be assigned to A after 10 seconds. Sorry, after 10 nanoseconds. So this whole statement is only executed after 10 nanoseconds. So that's what the difference is. Intra means between the instructions. Yup. Yeah, you're correct. Where we use try data type, like where the I don't know, because there is one difference that try-rich data type has, that it can have. This one is the try-rich data type can have this large, weak, and medium things. Other net types do not have this large, weak, and medium. This is one thing that try-rich have. So I haven't used this, but this is one point to be noted actually.
Hi, I have a doubt. Like, if the register is defined, but it was not assigned any value, what is the default value for that register?
Register is X. right? Default value of register is reg is X, wire is Z. Try is of all the net data types we have, all of them has a default value of X except the try reg. That's what I have. You understood?
Okay, only the reg and try will be having X remaining all, or I didn't get it. Can you repeat again?
And reg has a default value of X. This just have this in your mind that 1 second. The wire has a default value of C, and this is, it's not like a nets. It is also a type of net only, this try. It's like a type of connection only. It's not used to save any value. It's just doing for the connections. But this is the exception that it has a default value of X. Reg has an X. Just understand that. I don't think so anybody uses try. So for your understanding, you use default value of reg as X, wire as Z. That's it.
Okay.
So this try is not a different data type. It's not like storage thing like reg registers. It's a part of net only for doing the connections. Okay. You
So
understood,
anyone
right?
have any doubt? Anyone have any doubt now? Like this was the revision class, not the full class. So if you are the beginner, there may be many things which you have not understand. So for that you have to register for the classes, because this was the demo class. In this class we can cover all these things revision only. But if you are facing trouble, then go for the registrations, like for the course, complete course, in which we are covering the Verilog theory. Verilog, like it is like complete course. You can see on our YouTube channel, course videos are there, or you can personally pinch me. I will send you the syllabus. It is a complete course with a placement. So if you are facing any problem, then go for the course. Otherwise, if you are understanding the things, then you can go for yourself. Right? That will be also fine. So we are ending this meeting. If anyone facing any problem, you can pinch me on the WhatsApp. Okay. Thank you, Akshima. Thank you, Nikhil.
Thank you. Thank you, everyone.
Thank you. Thank you so much.
Thank you, everyone.